In this session, I'm going to give you a conceptual understanding of the association rules, which is one of the important aspect of machine learning, which plays an important role in the marketing domain, where I want to do a market basket analysis. Right? Typically, we see a lot of scenarios where uh, whether it is Amazon, where it gives some kind of recommended products for us based on our purchase history, or even when you talk about Google AdWords kind of stuff, depending on what is our browsing behavior, we are seeing the ads that are appropriately targeted towards us. So all these are typically the outcomes of the association rules itself, right? So understanding these association rules and what kind of role they play in the market basket analysis is very much important. So in this session, I will be looking at purely the conceptual part behind these association rules, and we'll take up an example, a live example data set in R, and we will try to execute this entire market basket analysis in R in our next session. So just looking at the major aspects, I'll be talking about what is the basis for these association rules. We'll try to understand some of the concepts, some of the definitions, which are more and more linked with the association rules. And we will also spend some time in terms of the metrics. What are the different kinds of computations that are performed while while interpreting the association rule? So these are the conceptual aspects that I am going to look at in this session. So if I look at from any company's standpoint, they maintain huge records of consumer transactions today, right? They have volumes and volumes of records, daily transactions. So the kind of data they are maintaining, thanks to the various databases and the cost of reduction in the usage of IT, cost of reduction in the costs associated with IT, we are seeing that every organization is maintaining tons and tons of data. Records are too many in number. So they have lots of information regarding the various products that people have purchased together. If I look at all the transactions that have happened on Amazon, they can very well have different kinds of products that people have purchased together. The services that are tracked across time, right? And I look at a website, so I keep browsing a few websites one after the other. So based on my browsing behavior, there is a sequence of visits that is being created, different customer support calls. So you could see data wise, there is a huge volume of transaction data that is typically captured by the organizations. Now, when I am talking of the association rules, I want to understand the patterns in all these things. One of the main works for me is based on all these transactions. I want to understand some kind of patterns in each of the transaction, so that I can very well understand the purchasing patterns of the customers. I will have to understand what kind of customers are purchasing what kind of a product. When they have purchased a product X, what is the likelihood that they will purchase product Y? So can X and Y be bundled together as an offer, right? How do I really optimize the pricing? Can I club one more product along with XY and set the price of these three things as a combo? I can understand the purchase patterns, the relationships between the various items that are getting purchased. All these kind of things I should be able to analyze, so that I can make my pricing decisions accordingly, I can make my promotion decisions. In many cases, we see that if you buy this particular product, the another product is packaged along with it as free. Or the other way I look at it is, right, all the products are packaged together and say it's a combo offer. All these things are purely based on to what extent people are purchasing the products together. Or if I buy some X and Y at a particular store, they will try to say Z is recommendation for you. Now all these are really helping the marketers to make their promotional campaigns, to make their pricing campaigns, to make their bundling of the products based on the various transactions that have occurred in the past. So here, when I'm capturing that kind of a data, simply doing the correlations and linear regressions will not work, because huge volumes of transactions are there, and each transaction, the kind of information that it conveys is very, very little. So I can't have the regular simple regressions or correlations kind of analysis in these contexts. So I have to go for something advanced, and this is where we are positioning this particular aspect called association rule mining. So I'm using some association rules. We have a package for this in R called as A rules package, which is association rules. In the association rules mining, we are trying to get some kind of insight from the various transactions. We examine all the various transactions that have occurred. So when I say a transaction, we'll define the word transaction, but when I'll take all the transactions, and based on the transactions, I try to get some insight. Especially, I would focus on the co-occurrence of the items within the transaction. Which items are purchased together? What is the sequence, one after the other? What kind of pages are typically visited? So that is where I'm focusing on my association rule mining algorithm. So it's a hardcore machine learning algorithm, right? We can use it very heavily in analyzing the entire set of transactions that have been purchased, transactions that have happened, and within the transactions, what is the kind of co-occurrence that has occurred. So I could primarily, I'm looking at some kind of patterns from very huge data sets, and this is the major objective behind the association rule mining. Of course, though I'll use these rules for transaction data, but let me tell you, even with non-transactional data also, I can use these kind of rules. The same kind of association rule mining is applicable even in text analysis also today. So association rule mining is a very generic kind of machine learning algorithm which has applications in various domains, and one of the most popular domain where it is typically being used is the marketing domain, where we are calling that as a market basket analysis, right? So just talking about the association rules, we'll try to define some of the terms so that we can use them more confidently when we have taken a data set and we are trying to make some kind of interpretations based on the data set. So here we talk about the activities or items being purchased together. Events are occurring together more often than what I can expect from their individual rates of occurrence. So let's assume that, okay, I'm selling something, product 1 and product 2, right? So overall, let's say I have I have made 500 transactions, right? So within that 500 transactions, product 1, there are 50 transactions where product 1 is present, and there are let's say 100 transactions in which product 2 is present, right? Now, I want to really know in how many transactions product 1 and product 2 are present together. Let's say 30. Right? Now you see this. Product 1 is sold 50 in 50 transactions. Product 2 is present in 100 transactions. Product 1 and 2 are present in 30 transactions. What does this convey to me? If I really try to look at this, right? I want to know whether there is some kind of association between product 1 and product 2. So simply look at it. If product 1 is purchased 50 transactions out of 500, which means the chance of product 1 featuring in any of the transaction is 10%. Now, if it is completely independent of product 2, what we say is, out of this 100 transactions where P2 is purchased, P1 should be purchased only 10% of the time, which means only in 10 transactions, if P1 is present, then I can say P1 and P2 are independent. So this is what I am saying. Their individual rates of occurrence is, because overall it is 10% of the transactions, even within this 100 also it should occur only 10% of the time. If there is nothing of a kind of association that is existing between the products P1 and P2, it should come exactly in 10 or approximately 10 transactions. But what I am seeing is they are coming together in 30 transactions, which means there is some level of association between the two. Probably those people who have purchased P1, they are purchasing P2 as well, or it is the other way around. Now this kind of co-occurrence is a kind of interesting pattern for us, is a kind of pattern for us to evaluate. So this is what I am trying to say here. Two events, when they are occurring together, more often than what I can expect from their individual rates of occurrence. The individual rate of occurrence of P1 is 10%. So even when P2 has occurred, if it occurs only 10% of the time, then I say there is no association pattern, there is nothing of co-occurrence that is occurring between these two products. So, but if this is completely a different number, that is what we are calling as co-occurrence, and co-occurrence is the most important pattern for us to analyze when we are using our association rules. So when we are using the word association itself, we are talking about the co-occurrence of two or more things happening. But let me tell you, this co-occurrence need not be strong kind of scenario. It could be just occurring just like that. So it need not be a very strong association as well, but it should occur. It's much more than a simple chance. Then we are using another term called set of items. Very simple word, one or more items. We typically represent them in this association analysis using these braces. Then when we use the word transaction, it is purely a set of items that co-occurs in an observation. Those set of items that come together in an observation, that is what we are calling as a transaction. So if I have purchased 50 items in one single transaction, that is a transaction. All 50 items are purchased together, right? So all 50 pages are visited one after the other, right? That's a kind of a transaction. Set of pages visited during a session, set of items that are purchased together. So wherever you can take it as a set of one or more items that are purchased together, that are coming together, that is what we call as a transaction. Then the other definition, which is the key for this session, market basket, it's what we call as a transaction unit. One unit of transaction is what we call as a market basket. So if I say one transaction, I have purchased 50 items, this 50 items is one basket for me, right? I have purchased all 50 items in this particular basket. So one transaction, I'll call it as one market basket in the world of marketing. So those set of things that are purchased together, or that are planned to be purchased together. That is what we call as market basket. And one more term we use in this context, it's a rule. So it expresses some kind of incidence across the transactions. So when one item has been purchased, when P1 has been purchased, we are trying to look at how many times P2 has been purchased. So which is like P2 conditional on P1. This is what we are calling as a rule. Right? The incidence of P1 or the incidence of P2 as a condition that P1 has already been purchased. That is what we are calling as a rule. So here the relationship can be just between two items or between two sets altogether. P2 itself could be a set here, P1 itself could be another set here. So given that this set of items have been already purchased, I want to see how many times the other set of items are typically purchased. Now this is nothing, it's nothing to do with the causal relationship, it's only an association. And let me tell you, this association always need not be strong, it should exist. It is just more than a chance. So these are some of the definitions that we put up in understanding the association rules. Then a few computations that we typically do. Right, when we are using this association rules or market basket analysis, we have a few terms that we should focus on. Support, we should understand this terminology well. Confidence and lift, these are the three terms that we need to be comfortable with. When I am saying support, so as I have used in the earlier example, there are 500 transactions, right? Let me take this example that will give everything for you. 500 transactions that have happened all the day. Product 1 is present in 50 of these transactions. Product 2 was purchased in 100 of these transactions. Product P1 and P2, both of them have been purchased in 30 of these transactions. Now giving the definitions here, when I say support, so support of P1 is nothing but out of the total set of transactions that have happened, in how many transactions is P1 present. So 50 out of 500 is the support for P1. So let me call it as 10%. So I will define it separately for every unique set of items. So it could be one item or it could be a set of items. But support means how many times they have come together out of the total transactions that have been performed. So I'll have to understand what is the support for each product or each set of products. Then confidence. Now I want to talk about the confidence of Y given X. This is how we represent. So which means assuming X has occurred, X has been purchased. So here I'll say confidence of P2 given P1 has already been procured. Right? P1 has been procured, it leading to P2. Right? I have procured P1 and in how many cases where P1 is already procured, I am talking of procuring P2 as well. So here P1 is procured 50 times, out of which P2 is also present 30 times. So the confidence of P1 given P2, right, or P2 given P1, which means P1 leading to P2 is nothing but whatever is the number of times both have been procured, which is 30, divided by the support that is existing with respect to P1, which is 50. So 60% is the confidence. So it's a support for co-occurrence of both of them. So co-occurrence of both of them is 30 out of 1000. That is the support for co-occurrence of both of them. conditional on the support for the left hand side alone. Support for P1 alone. Support for P1 we have already computed 50 by 1000. So it works out as 0.6. So this is how we compute support for both x and y divided by support for x. So which means there is a 60% chance that if at all P1 is procured, that P2 also will be procured. So this is what we are calling as confidence. But let me tell you, it's not symmetric. P1 leading to P2 is different from P2 leading to P1. Right? You could see here. Because numerator is support for both P1 and P2, which is 30 by 1000. But the denominator is support for P2. P2 is coming 100 times. So support for P2 is 100 by 1000. And overall the confidence is only 30% here. So we really say that confidence need not be symmetric, but this is how we compute. Another term that we compute in the association analysis is the confidence. Then comes the understanding of lift. The lift is given with the formula. I'll take the support of both of them occurring together and I divide it by both the individual supports. This is what we call as a lift. Now what this simply says is, it's a support of a set conditional on the joint support of each of the elements. So if you see the same example, right? So earlier we have got the support of x intersection y is 30 by 1000. Support of x is 50 by 1000. Support of y is 100 by 1000, right? Now if I do the calculation here, it becomes 300 by 50, which is otherwise 6. So what it says is the combination, right, of both x and y, P1 and P2, it occurs 6 times more often than we would expect if these two terms are independent. If these two terms are independent, as I said, it should come only 10% of the time, right? It should come only 10% of the times. When P1 has occurred, P2 should come only 20% of the times. What is that? Okay, now P1 leading to P2, right? So we are saying P1 has come 10% of the time, P2 has come 20% of the time. Now, if P2 has come 20% of the time, if both are independent, even within this, P2 should typically come if they are independent. If this has come 50% of the, if this has come in 50 transactions, right? So this one also should come in 20% of those transactions. So I think it should be, so it is saying if they are independent compared to their independent, so it should come how many times? 5 times, right? 10% of 50, which is 5 times, but it is coming 30 times, which means it is 6 times more. The combination is occurring 6 times more often than what we would expect if they are independent. If they are independent, both should come only 5% of the times together, or 5 times together, but they are coming 30 times together, which means the lift is 6, which means the combination is occurring 6 times more often than what I can expect if both of them are completely independent. So which means the higher the value of the lift, the higher is the chance that they are coming together rather than coming completely independent. So when I am doing my models in terms of identifying the rules, I have to set some minimum threshold value for the support, right? So I want to see the items that are getting purchased at least this many times. and I need to have strong conditional relationship with respect to the other. So the confidence should be much higher. So once these two are there, and along with that, I want that they should have very high lift. So I want at least the minimum number of transactions in which a particular item is purchased. So my support level, I'll set it at some minimum level. Based on this support, I want those products where the confidence levels are much higher. So whichever the other things are purchased quite heavily with respect to this particular product. So I want the confidence levels to be much higher, and both of them leading together to produce a very high value for the lift. So wherever I see the higher values for the lift, I can take them as items that are typically purchased together, and basically all my pricings and all those decisions can very well revolve around these items that are procured together. So that is what is the conceptual part behind the usage of association rules and behind the market basket analysis. So these are the things that we have looked at in this conceptual overview. If you are comfortable with this, we can very well use this on a data set to really understand what the R-based A rules package is extracting, how it is trying to identify the co-occurred kind of products, co-purchased products in transactions, and what are the kind of rules that it is creating which can help us in designing the products and designing the combo offers more and more effectively. So if you have any further queries regarding the same, you can get back to me by giving me a call on the number that I have given below. You can even send in an email at vamsidhar@acegurus.com. Thanks a lot for listening to this session. Thank you very much.